Alrighty guys, welcome to the third and hopefully final installment of setting up Creo for manufacturing. Today we'll look at using Austin NC's GPost and the option file generator to make a post processor that works for translating your machine's G code. So some of the things you'll want to know for this as far as configuration options go, you go to our configuration editor. You're going to want to know your CL directory, which is the default place that your Creo is going to post your programs, and also the Creo cutter location files, which are the files that Creo translates through Austin NC into the G code for your machine. You're also going to want to set your NC post type to GPost, and finally to use GPost processor directory to set the directory for where you're going to put your GPosts. And those are all folders that you can decide ahead of time as to where you want things to be put for your own convenience. Or you can make your posts and make the folders later. To get to the option file generator, which is how you'll make the GPost to convert code to your specific machine, you start in the backstage of Creo and drop down Utilities and go to NC Post Processor. If that is grayed out, odds are you don't have the manufacturing license for Creo, and you'll have to contact PTC about how to get a hold of that. And this is the option file generator. Now, this is a effective but somewhat kludgy system, I guess you could say. It works, but it's not the highest tech. You're not going to be using this like you would Microsoft Word or Excel. It's not that convenient, but it does get the job done very well. And part of this thing's little quirks is it's not very compatible with a lot of modern computers right out of the gate. So what you have to do is find the executable file that this runs off of, which is I just located it takes you a while, your default Creo installation. So whatever version of Creo you have, go to Common Files, this x86e Win64, and then obj. That listing of files there, and eventually scroll down until you find this file down here, this opt file with the little wrench and screwdriver. Right click on that, properties, compatibility, and you can change options back and forth and all that. You'll have to find out which ones work for your particular computer and monitor setup. However, without that, all these buttons will appear really tiny and misshapen, and you will barely be able to use this utility. If you go to XE Win64 and then to the GPost folder instead of to the OBJ folder, you can find that there are many default post processors that Creo comes with. And so let's copy that address and open up one of them. So you can see there are lots of different default mills. Like there is a Fadal, which I actually used for a long time that we had up at school. So let's open this one. And in order to do this effectively, you're going to need to know a lot about your machine. You can't just say, oh, I bought this machine, I'm going to make an option file for it. You have to know that machine in and out, because any one of these options that is incorrect or not quite right, when you try to flip a switch in Creo or program a new type of maneuver, you could very well end up with a crash, and that actually happened when I was using this and had to make an advanced fill routine. We'll get into that in a couple minutes. So you can see here on the left there are various different things, and this gives you machine, and you can tell it how many axes you have, other things like that. And a wire EDM would be done the same way. It would be done as a mill, but with some different commands. And I am not very familiar with the wire EDM post processor per se, but there are some default ones that come with your Creo manufacturing that you can look through as guides. A lot of fancy stuff that I've never had to deal with up through here. File formats, this starts getting important because this is going to be where you address special things specific to your machine. So this is going to be mostly standard G code. You know, you have X, Y, Z, I, J, K. But if your machine has a couple of weird codes that are not standard, you're going to need to set those here for your different letters. You'll also set things in this page on decimal places, etc. by going to, say I want to edit I, I'm going to edit selected address, and you can edit that all here. And then if you want to, you can specify your own extension. So say you want your programs to be output as .nc, you can put that extension here, even though really no matter what it is, it's still a generic text file. It just might be the file extension agrees with your machine better. List file, this is when the Creo translates your file through Austin NC's gpost. It's going to take the cutter location file that Creo generates, run it through a post, which is what this option file generator defines, and as it does that, it's going to make a list file telling you how it translated each line of the cutter location file. And so this helps you when you're trying to proofread and check your G code. Say you program a simple part in Creo, say one that has contours and holes, because that'll cover most of what a milling machine will do. Post that and check it line by line to make sure it's doing what you think it's doing. And that list file can help you identify which line it translated incorrectly. We'll look more into examples of list files later on in the video. Sequence numbers are just like what they sound like. These are your block numbers. And simulation file never used. HTML packager, this packages it as an HTML file altogether if you want. Something I've never really used. Start end of program, this sets your preparatory blocks for all the things that happen at the beginning of the program, you know, where you set your G20, G90, etc. every time as your safeguards at the beginning of the program, and also your beginning end of program characters. For motion, this is going to tackle stuff that's mainly if your machine does something weird, like for example this Multax thing that they refer to, which I think is for the 4 and 5 axis motions. But you can customize how your machine moves in circles and also for all your different hole cycles, which also gets into machine codes. So cutter compensation, M codes, if you've got different types of coolants and different stop codes. Feed rates, how do you like that? Do you want them in units per revolution or units per minute? Fixture offsets, this one is important for the fadals because the fadals use an offset E as opposed to a G54 like most Haas or Fanuc controls do. And this is stuff that I'm going over it in a very bird's eye viewish, but this is kind of where you have to know your machine and know what it likes. For example, like I was saying with the fixture offsets using E1 instead of G54. That's important to know, but Austin NC has great documentation, but it's not going to come out there and tell you, hey, a Fadal uses E1. You have to be the person to know your machine. Operator messages, I've never really used that. Advanced, this, like it says, is advanced. Austin NC's gpost option file generator can be modified beyond the options we listed above to suit your own special needs with a crude but effective form of programming called Factory Interface Language, or FIL, F-I-L. So this has a bunch of different macros in it. And programming this is something I have done. We can look at an example program later on, but it's rather time consuming. You don't get to necessarily name variables like you would in a traditional programming language. You have to call them using these postdef functions. And that gets kind of sketchy. But good serendipitously for you, In that same gpost directory where we found all the example posts, there are also the manuals that Austin NC published with this programming language. And these manuals are actually very helpful and provide a lot of good examples. So if you're looking to do something very complicated, odds are someone that knows how to do that is going to be hard to find. But you might be able to put in a lot of time and effort, study these manuals, and come up with a code that suits what you're looking for. So let's close out of this particular option file. No, I do not want to save. Let's look at the one that I made for the Fidal up at school. And this one is going to have a lot of confusing fill routines that I don't even remember what they do anymore. So this one, it's very hard to find a post processor that works with subroutines oftentimes, but this is one that I programmed to use Creo's subroutine building function. So if you wanted to make, say, 4 vices run 4 parts at a time and use subroutines to run through each tool at a time, now I can do that. And the way it does is it basically runs through the entire program in a loop the whole way through, then jumps back, and when it's running through, it counts all the times that the CL file says, hey, I've got a subroutine. And then it'll count on all of those, and then it'll insert the codes where Fidal wants the L100 to call the first subroutine, etc. And somewhere in here there is a macro for, yes, Fidal's rigid tapping, which uses G84.1. And this macro is kind of switching around a lot of the codes because Fidal, for some reason, decided that Q is going to be the pitch of the screw, and that F, the letter F for fish, is going to be the RPM, which you would usually think would be S for spindle and speed. And on a Fidal, it usually is. But in this particular G84.1 can cycle, the letter F is for spindle speed, which is why you need a complicated macro. And there's the end of the fill file. So every time Creo will convert a file from its cutter location file to a G-code file for your machine, it'll read through the option file and translate stuff, and then through the fill file and translate stuff as the fill file demands it. And so let's look at the process of posting a Creo NC file. So here is a NC assembly that I programmed a long time ago. This is a gear case for a small Baja off-road dune buggy. So I've already got everything programmed, so let's save a CL file for an operation. Let's do op1, click File, MCD file, compute CL, done. And it's going to bring me to a directory, which is that directory that's in our configuration saying where to put the NC files. And so I can name my operation, and I'm going to say it's important that you rename the files as you post them and don't settle for a default name, because sometimes I've had Creo have issues trying to replace files of the same name and they get corrupted and then it can't post the code correctly. So make sure you keep renaming files and don't just repost with the same names over and over again without either renaming or deleting the old files with the same names. And you'll notice it's going to save a file that's called a CL with an extension .ncl, which is your cutter location file that's in Creo language. Click OK. And it's going to do a lot of thinking as it goes through all of the toolpaths. Alright, now just to make sure I select the correct post processor, I'm not going to check machine, which will use the post processor ID number that's in our work center like we defined in the previous video. So I just click done, and then it should prompt me for which post, and I know I want number 39, which is my Fidal with subs, as you can see in the lower left corner there. and it's going to ask me for a program number, and I'm going to say 1999 and hit enter. And you should say done output, and it'll give you this little window saying, okay, everything went great, hopefully. If you see warnings and errors on here, then you'll want to go look for the list file. So let's pull this up and see what happened. So we can see our NC file and this Creo version file, which is our NCL. So let's open this, and we can open this, which is a plain old text editor. And here we go. This is the cutter location file. And notice this isn't G-code, as you can tell, but it does tell you things. It tells you, hey, use a fixture offset, in this case, fixture offset 7. Use the coordinate system in this orientation. Turn the spindle on, turn the coolant on, use rapid travel. Go to this location. So that's G0. Cycle drill. So now we're going to work on a G80 series cycle. I'm not sure exactly which one this is. Depth, so that's probably PEC drilling. Turn the cycle off, so that's your G80 cancel cycle. Go to a point, and so this is basically a G-code program, just not written in G-code. This is Creo's language. So that will get translated, and so if we look at our list file, that details the setup of the option file, which is long and without ending, and also details the translation of each line. So right here you can see calling macro. That's saying that this particular line is using a macro called output from the fill file program to translate this line. And then that results in the NC file, which I have my option file set up to name the NC file with the operation number. And so you can see here is that completed program. You notice down here is our G81 for that canned cycle that was at the beginning of the program. And here are comments that are set by my print file to say output the name of the part, output the sequence type, and the tool I'm using as comments. And there we go. So that is making an option file for your Creo NC manufacturing database. Thank you for your time, guys. I hope you enjoyed this video, or if you didn't enjoy it, it might have been a little boring, but I hope you at least learned something. If there are questions I haven't addressed, feel free to leave those in the comments below. And if you'd like to see another demonstration example of programming with Creo, perhaps with a mill or maybe even some more wire EDM, let me know that as well. Thanks for watching. Have a great day.